Good day everyone. For today's lesson, we're going to tackle about Introduction to Mathematical Models. This will be presented by Group 1, which is Miss Harion, Miss Leong, Mr. Tipon, and me, Miss Rudas. Objective. So, at the end of the lesson, the students should be able to explain the concept of mathematical modeling and distinguish among the different types of mathematical models, construct a mathematical model to represent a real-world problem using appropriate variables, assumption, and equation. Demonstrate appreciation for the role of mathematical models by actively engaging in discussion and valuing their application in various fields. So, what is mathematical modeling? Mathematical modeling is the process of using mathematical concept and language to describe and analyze the real-world system or phenomenon. It involves translating a real-world problem into mathematical terms such as equation or graphs to gain better understanding of it and to make a prediction. So, here is the step. When we say mathematical modeling, di ba, hindi na siya words. I-transfer mo siya, yung words, i-transfer mo siya into mathematical concept. So, pag once na mayroon kang problem solving, ito yung mga step na makakatulong talaga sa'yo to better understand the problem and also to make a prediction or yung magets mo yung sagot or magets mo kung paano kuhain yung sagot. So, these are the steps. First is research and brainstorming. Under the research and brainstorming, there is define the problem, make assumption, and defining variables. So, first, define the problem. Di ka naman nandun para lang sa so kailangan mo alamin kung ano yung problema. By knowing the problem, you can make assumptions. So, pag sinasabi yung assumption, ito yung mga bagay na pwedeng yun yung maging susi para magets mo, malaman mo yung results. So, yun assumption. Next is defining variables. Ano nga ba yung mga nandun sa problem na yun para ma-solve mo siya. Next is getting a solution. So, by knowing all of those three under research and brainstorming, you will get the solution or makakagawa ka ng solution para dun sa problem. Next is analysis and model assessment. So, di lang naman porket may solution ka na okay na yan, ganon, hindi. So, by analysis or kailangan mo isa-isahin siya. Tama ba yung variables mo? Tama ba yung sinosolve mong problem? Yun ba talaga yun? Or hindi? Or tumama ba yung assumption mo? By knowing this, you will now know the result or report the result by, again, start tayo ng research and brainstorming. Under ng research and brainstorming, you should define the problem, make assumption, and defining variables. Next is getting a solution. Next is analysis and model assessment or iisa-isahin mo kung tama ba yung mga ginawa mo. Then, next is report the result or yung ihahayag mo na kung paano mo nakuha yung result mo.
My name is Hershey N.C. Haraon and my part is the types of models. So, ito yung iba't ibang types of models na na-research ko. First is discrete versus continuous, static versus dynamic, deterministic versus stochastic, linear versus nonlinear, explicit versus implicit. So, ano nga ba yan? So, discrete model represent a system in which variables can change only at specific separated points in time or can take only distinct numerical values. These models are appropriate when dealing with quantities that can be counted, such as people, animals, or manufactured items. It frequently involves different equation or finite sequence. So, this model used when things can be counted one by one, and the numbers are separate and not connected. Remember that it only changes at a specific time or moment. So, continuous represents system where variables can change smoothly over time and can take any value with a range. These models are appropriate for a phenomena such as temperature, velocity, fluid, and chemical concentration. This often involves differential equations. So, it is often used when something changes smoothly without breaks. The values can be number or even in decimal. Remember that it is usually changes all the time, not just a certain point. Kasi kung yung discrete model ay hindi siya nagbabago, it remain constant, yung continuous model palagi siyang nagbabago. Wala siyang exact na sagot or outcome. So let's proceed on. So here are the examples of discrete and continuous model. The number of cats in the neighborhood. Syempre pag nagbibilang tayo, hindi naman natin bibilangin yung mga pusa na 1.1, 1.2. Syempre 1, 2, 3, 4 in a form of whole number. So score of student in exam, your exact age, the number of books on a shelf. Mapapansin natin that yung example ng discrete model has no wala siyang butal or wala siyang point na wala siyang sobra, exact siya. Yung continuous model naman, the speed of a car, the height of a student, how long students ate breakfast, winning and time race, temperature of hot water. Dito makikita natin na may mga butal to, may mga ginagamitan to ng decimal points. Hindi siya palaging whole number. So, here the illustration of this model, discrete and continuous. Mapapansin natin that this graph, yung graph ng discrete and continuous ay magkaiba. So, where you can see that in discrete, it appears as individuals, dots, or points. Nakikita naman natin. So, kung makikita natin sa bawat dots na to, may gaps where you can able to count the values. Unlike sa continuous, wala siyang gaps, dire-diretso siya. It show the values are measurable and can take any real numbers shown with continuous lines. Kasi, sa continuous kasi, yung values, yung range niya, values ng range is within the line. Hindi natin makikita siya. Dito mabibilang natin sa discrete kung ilan yung cost ng tickets, while in continuous, hindi natin siya kasi dire-diretso siya. So, the second types is the static model. Describe a system at a single point in time without considering how the system evolves. It is essentially a snapshot of a system, focusing only on the relationship between variables under fixed conditions. So, this model does not show changes or what happened before and after. It's like taking picture where we can only see what is happening right now. Somehow, it focuses on relationship between variables but under fix or under change. Under change condition. A static model, remember that a static model only show the current situation, not how things change over time. So, dynamic model describes how a system changes over time. Time is an essential variable and the model captures transitions, trends, or behavior over time. So, in this model, it shows changes over time. Mapapansin natin sa static, hindi mahalaga yung time. It doesn't care when it comes to time. While sa dynamic naman, time is important in this model. It shows what happens step by step or how things decrease or increase. Laging tatandaan natin na yung dynamic is like, example is like a video na hindi nagpapakita ng isang litrato lang. But how things change from one moment to the next. Unlike sa picture na kung ano lang yung makita natin, yun na yun. While in video, makikita na it doesn't just one picture but how things, kung paano nagbabago yung moment to the next, from one moment to the next. So next, so here are the examples of static model and dynamic model. The floor plan of a house, room sizes, wall locations, and doors and windows. Organizational chart of the company. 3D CAD model of a car. So, while in dynamic, weather forecast model, temperature changes, wind movement, storms forming, humidity variation, traffic simulation for a city, population growth model, stock price prediction mode. So, I have here illustration of these two model. Makikita naman natin that static has nothing changed. Only the red groups may adjust, and it has a fixed position and doesn't care in time. While yung dynamic naman, makikita naman natin na yung two groups change over time. In this model, both groups can move and its position changes moreover and it includes times and motion. So next, so yung deterministic model and stochastic model. Deterministic model in which all parameters and variables are known with certainty and produce a unique, predictable outcome. There is no randomness. Remember that there is no randomness involved. If the initial conditions are repeated, the model will always produce the same result or outcomes. So, in deterministic, everything is known and certain. There is no randomness. If you repeat the same input, you will always get the same output or result. While in stochastic model naman, includes one or more random variables, meaning that outcomes are not perfectly predictable. Instead, the model describes probabilistic behavior and repeated simulation may yield different results. So, in this model naman, you can predict the outcome of it. Like a math formula, always give the same answer when the input is the same. So, kung yung deterministic is walang randomness, yung stochastic model naman, it includes randomness or uncertainty. The result is not always the same. Unlike sa stochastic naman, na sabi ko kanina na yung result niya is the same. If the input is same, the result is the same. So, it gives probable outcomes, not exact ones. For example, like predicting a weather, it's always never 100% accurate yung prediction na yan. Only likely lang siya. So, here are the examples of this model. Deterministic model, projectile in motion. Car acceleration, population growth without random events. Stochastic model naman, weather forecast. Andito yung temperature, humidity, wind patterns, atmospheric pressure. Next is stock market prices, customer arrival in a store. Nakita naman natin yan. So, here are the illustration of this model. So, makikita natin, ito yung deterministic, which has a single line. Yung stochastic naman dito is, ito yung may iba't ibang kulay na to with a different lines. So, in deterministic, the left graph shows single smooth curve. In short, it always gave the same input, it always give the same output if you start the same input. And it has no randomness involved. Makikita naman natin. Isa lang yung output niya. While the curve is smooth because the outcome is predictable. Napipredict na dito yung lilinawin natin. Deterministic, predictable na yung outcome. If you put same input, you will get the same output or result. While in stochastic, if you put same input, you will get a different output. Or in short, it shows many wiggly or noisy curves which all start at the same but moving differently. Makikita naman natin na nag-start sila dito sa same input but goes in different way. Yan yung stochastic. Wala siyang accurate or exact na result or outcome. So, next model is the linear model and nonlinear model. So, lagi naman nating naririnig yung dalawang to. So, linear model is a model in which the relationship between variables is proportional, additive, and can be represented by straight line. Remember, alam naman natin na when it comes to linear model or linear function, straight line lang siya. So, sabi nga dito, yung linear model has the relationship between variables is proportional and additive. When variable changes, the other changes in constant and predictable way. So, the relationship between variables is not proportional or constant sa nonlinear model na to. Kasi yung sabi dito sa nonlinear model, a model in which variables do not have a strict proportional or additive relationship. Walang relationship yung dalawang variables. So, yung variables is not proportional or constant, tsaka nagbabago siya pero hindi laging parehas. Tsaka yung graph niya sa nonlinear, magpo-form siya ng curve or not straight line. Unlike sa linear, lagi siyang straight line. So, mayroon ako ditong example ng model na to. So, sa linear, salary based on hours work. Buying fruits by weights, electricity bill, taxi fare. Sa nonlinear naman, circular garden area, population growth, car braking distance, dose response. So, ito nga yung illustration ng dalawang model na yan. Sa linear, makikita natin dito that it show a straight line with a constant slope. Well, yung nonlinear naman, it show a curved line. Ang tawag sa line na to is cubic line with changing slope. Nagbabago yung slope niya. Yung linear, constant slope. Remember that. So, next model. So, the next model is implicit versus explicit model. So, ano nga ba yung implicit? expresses a relationship between variables without isolating one variable on one side of the equation. So, in this model, the equation shows a relationship between variables but no single variables isolated on one side. So, the variable are mixed together in equation. We cannot easily solve for one variable directly. For example, x squared plus y squared equals 25. It's saying that all parts are connected, but no single part is focused. Diba? Kasi connected yung x squared plus y squared sa pagkuha ng outcome. Yan yun siya. Hindi ka pwedeng kumuha ng hindi mo pwedeng unahin yung isa. Hindi mo pwedeng kunin lang yung isa. Kasi yung y squared tsaka x squared is connected to each other. These two variables has a relationship. Next is explicit model. Expresses the dependent variable directly in terms of the independent variables. In this form, one variable is isolated on one side of the equation. Kung kanina yung implicit model, hindi siya naka-isolate. Sa explicit model, naka-isolate yung one variable. So, ano nga ba yon? So, in this part, the focus of the equation is isolate one variable on one side. Yung dependent variable is clearly expressed in terms of independent variables where you can directly calculate the value of one variable. Diba? Naiintindihan nyo ba? Kasi yung sa implicit model, hindi mo pwedeng i-calculate yung isang variable lang. Kailangan yung dalawa. Kasi may relationship nga yun. Yung explicit model naman, sa explicit model naman, makakalculate mo siya kahit isang variable lang. Makakalculate mo yung value of one variable. For example, y equals 2x plus 3. Where y is clearly solved in terms of x. It's like giving a clear instruction where if x is this, when y will be that. Gets ba? So, here are the example of these two models. The implicit model is, ito yung example niya, circle in a garden design. Car path on a curved road. Temperature in a pressure relation lang siya. While sa explicit models, simple interest in savings, distance traveled at constant speed, temperature conversion, selling product with profits, tapos area of a square. So, I prefer an illustration of this model. So, here, makikita natin dito. Ito yung sinasabi ko sa inyo. Implicit means y is not isolated. The relationship between x and y is defined together and its graph can loop, turn, or break the vertical line rule. Nakikita naman natin parang nagki-curve siya na ewan, di ba? While sa implicit naman, makikita natin straight line lang siya. So, while in implicit, it means solve for x lang. It's solve for x. While this, it's solve for x and y. Which one y value for x and its graphs are a standard function. So, bago natin ipasa sa next reporter, I will recall the 5 types of models that I discussed. Discrete and continuous model, sa discrete and continuous model, ang ano natin dyan, counted and whole number. Continuous model is in a form of measure, it can be decimal or in fraction. Sa static model naman, it remains constant, hindi siya nagbabago. While sa static and dynamic naman, nagbabago siya. It changes over time. Deterministic and Deterministic and stochastic. So, deterministic naman, siya? Napipredict mo na kung ano yung outcome. Kasi, sabi doon, kung if you put the same input, it has the same output or result. While sa stochastic naman kasi, kung naglagay ka ng same input, it has a different result or output. Yung linear and non-linear model naman, laging tandaan, pag linear, straight line. Non-linear, it can be on a curved line or not a straight line. And lastly, implicit model and explicit model. Sa implicit model, it has a relationship between two variables na dinadefine mo, and ang graph niya can be loop. While sa explicit model, yung dinadefine mo lang is yung values ng y, where y value for each x and its graphs are standard function. So that's all. I will pass this part to the next reporter.
Good day everyone, I am Joshua Tipon, and today we were going to discuss about the applications in different fields using the mathematical models. Applications in different fields. In education, mathematical models help analyze test scores, track students' progress, and design grading systems. Teachers and researchers use models to understand learning patterns and improve teaching methods. This leads to more effective lessons and better student performance. In this statement, in education, mathematical models are used to analyze students' performance and patterns. Schools and researchers use models to predict outcomes, measure progress, and design effective teaching methods. Through data and equations, educational systems can improve instructions, monitor achievement, and understand what strategies work best. For example of this, tracking students' progress. Well, teachers and researchers use mathematical models to analyze test scores and attendance patterns. For example, they can predict which students may need extra help by modeling their performance over time. This helps schools improve teaching strategies and supports students better. Let's proceed to the next one, the finance and business. In finance and business, use mathematical models to predict sales, calculate profit, and manage budgets. Equations and graphs help businesses decide prices, plan investments, and estimate future growth. Models allow companies to make smarter financial decisions and reduce risks. In finance and business, mathematical models are used to forecast trends, calculate risk, and support decision making. Companies use models to estimate profit, analyze investments, and manage budgets. These models help business make smarter choices, reduce financial uncertainty, and improve overall performance. One of the examples of this is the sales forecasting. Businesses use mathematical models to predict next month's sales based on past sales data. The model helps companies decide how much stock to buy, how many workers to schedule, or when to launch promotions. This reduces waste and especially increases profit. Next is the engineering. In engineering, relies on mathematical models to design buildings, machines, and systems safely and efficiently. Models help engineers analyze forces, materials, and structures before building them. This reduces errors, saves cost, and ensures design work in real life. Mathematical models helps engineers predict the how structures, machines, or systems will behave before they are built. These models allow them to test designs, calculate forces, and estimate safety and efficiency. By using equations and simulations, engineers can make better decisions. Um, Sample of this reduce risk and improve technology. Best example of this is the bridge design, which engineers use mathematical models to calculate how much weight a bridge can carry. They model the forces, stress, and vibrations to be sure the bridge won't collapse. This helps them choose the right materials and structure before construction begins. And the next one, application in different fields, is the transportation and logistics. Transportation uses mathematical model to calculate travel time, fuel consumption, and best routes. Logistics modeling helps companies deliver goods faster and more efficiently. These models improve safety, reduce cost, and make transportation system more reliable. Mathematical models help plan fastest routes, reduce travel time, and optimize the movement of goods and people. They are used to schedule vehicles, control traffic law, and manage supply chains efficiently. These models ensures that transportation systems operate smoothly, costs effectively, and safely. Best example of this is route optimization for deliveries. Delivery companies like LBC or Grab use mathematical models to find the fastest, cheapest route to deliver packages. The model considers traffic distance and fuel costs. This reduces delays and save monies. That's all for my report, and it will be continued by Teacher Leo. Thank you so much.
Good day, sir. I'm Christine Leong from DSE 32M, and I'm continuation of application of mathematics in different fields, mathematic models in different fields. And to continue, let's start with science. Let's continue to science. Science uses mathematical models to explain natural phenomena like motion, energy, or chemical reactions. So these models help scientists predict outcomes, test theories, and analyze data. And almost 8% of math is 90% when it comes in physical science. And as you can see in the picture, we have sample of law of motions, Newton's law of motions, and physics, which is radioactivity. Next is a medicine and health. Okay, mathematical model help determine correct medication dosages and predict the spread of diseases. Doctors use database models to understand patient health patterns and make treatment decisions. So without math, it would be impossible for them to give a right medication for the patient. And math is essential in health and medicine for applications ranging from calculating dosages and analyzing medical imaging to modeling diseases and managing hospital resources. So these models improve safety, accuracy, and the quality of medical care. Next is environment and climate. Environmental scientists use mathematical models to forecast weather, climate change, and natural disaster. Models help predict rainfall, temperature, trends, pollution levels, and environmental risk. Though environmental and climate can be unpredictable sometimes, but it can be also calculated using some mathematical models. And this information guides governments and communities in protecting ecosystem and preparing for hazards. And next is technology and computer science. Technology and computer science use mathematical models to build algorithms, simulation, and software systems. So in technology and computer science, mathematicals have a huge part playing to create a system to analyze the pattern, to create a web for the computer science students. And as you can see, models help computer recognize patterns, predict outcome, and solve complex problems. They are essential for AI or artificial intelligence, apps, digital security, and almost all modern technologies. And to sum up everything that we've reported, mathematical models help us simplify and understand real-world problems by representing them through equations and relationships. Whether explicit or implicit, these models allow us to analyze patterns and make predictions, support better decision making. We hope this presentation gives you a clear understanding of how mathematical models work and why they matter. Thank you, and that ends our report.